Hello, everyone. My name is Mahmoud. The lead engineer at Xverse and one of the maintainers of the SATS Connect library. And in this quick guide, I'll be talking to you guys about how you can utilize SATS Connect to build your Bitcoin application. First, we will discuss what is SATS Connect and why you should consider it while you build your Bitcoin application. Then I'll be showing you how to get started using SATS Connect and where to find relevant resources. Then we will dive into a demo where we will be demonstrating how to use SATS Connect to interact with the Xverse wallet. Then at the end, I will show you guys some Bitcoin apps that currently uses SATS Connect in production, so you can see what will the final experience look like. So let's get started. So what is SATS Connect? SATS Connect is a simple JavaScript library that provides methods for developers to allow requesting some actions to be done on the user's wallet securely. Some of those requests include address retrieval, partially signed Bitcoin transaction signing, as well as message signing, which is coming very soon. So keep an eye on that. One thing also to keep in mind is that if you are using SATS Connect, your users will be able to use your app on mobile too, using the Xverse in-app browser. So that's pretty neat. So how can you get started? The easiest way to use SATS Connect right now is by installing it via npm. I would also recommend visiting the docs, which I'll be leaving the link to in the resources at the end. But first, let us go through features together for you to have an idea before you jump into the docs. So first, we have address retrieval, which is basically requesting a Bitcoin address from the user's wallet. Some of the use cases of this is user authentication, verifying that the user holds a specific asset, or constructing a Bitcoin transaction, and so on. So let's see this in action. So let's jump into our desktop. So this desktop exists in the docs that I told you about before, and it's pretty basic. So we have right now a button that says connect. I will show you guys how that behaves, and then we will jump into the code to see how that happens. So if I click connect, I will see the Xverse wallet pop-up appears saying that this app is requesting a Bitcoin address. And some of the details we can see here is that we have two types of addresses being requested. One is an ordinals address, the other is a Bitcoin address. So right now we support those two types. The ordinals address is a taproot address, and the Bitcoin address is a wrapped secret address. You're not required to request both, but you can. And then we have the account, which the user will choose which address he will or she will share with your app. In our case, we just have this one account. So if we approve this, we will see that the app right now have those addresses that we have just selected. So pretty easy, pretty useful. And that's it for address retrieval. One thing to keep in mind here that in the response from the wallet, Xverse includes public keys for each address that you can use to construct partially signed Bitcoin transaction, PSBTs, which you can use in the next request, which is signed transaction, or PSPT signing for now. So the PSPT is short for partially signed Bitcoin transaction, and it allows for interesting stuff like trustless swaps, for example, which is being utilized by Ordinal's marketplaces like Gamma. And it's pretty cool. Let's see how that looks as well. So if we go back into the test app again, and remember we have the addresses from the wallet right now, and we can use those to construct a PSPT. In order to construct, you can reference the guides in our docs. You can see it under creating PSPTs, where we have two examples of how to create that transaction for a wrapped segment address, as well as a taproot address using a library, a very popular library called BTC Signer. So if we assume that you have done that already, and I have, when I request to sign the transaction, I'll be seeing this. The user will pop back again, and it will show us some details about the transaction you're about to sign. So it will see you will see the amounts you're transferring from your wallet, as well as a detailed overview about what are the inputs and outputs that are inside that transaction, and specifically which input are you required to sign. So, and then you can approve it. You can see the warning here on the top. It says that this transaction will not be broadcasted from your wallet. This is something we can control. Like if in your app you are requesting from the wallet to broadcast that transaction, when the user approves, that will happen. If it's not, it will return the PSPT back with the user signature on it. If it's broadcasted, it will respond with the transaction ID of that transaction. So let's jump back into the code and see how you can use the signed transaction method to enable this functionality. So if you can see here on signed transaction click, which is the button handler from our test app, you will see we're calling signed transaction with those options. First thing is the network, which is specifying in which network are we broadcasting or signing this transaction, or are the addresses that construct the transaction from, is it testnet or a mainnet? A message as well to provide for the user to explain what are the consequences of this transaction, or why is the user required to sign it, as well as a base 64 PSPT, which we showed earlier, how you can construct using the guides in the docs, and a flag that says broadcast. The broadcast flag controls whether the Bitcoin wallet, in our case Express, will broadcast a transaction and returns a transaction ID to the app, or will the user just sign the input and respond to the app with the PSPT again? You're also required to provide an array with specific inputs you want the user to sign in the PSPT. And once you have all that, you send it to the wallet and the user approves, then you will receive either the PSPT back again or the transaction ID in the unfinished callback. And that is it. So simple as that. That's how you can use Sats Connect in your Bitcoin application. So let's get back into our slides. If we look at our case studies, we'll see two awesome applications, which are Gamma and Magic Eden. Both of them are marketplaces for ordinals and Bitcoin NFTs. So they are both very interesting project that utilizes Sats Connect. You can take a look at them and see how the experience looks over there with actual data and actual user interaction. So that might be very interesting. And that is it. So, like I said before, the best place to read about Sats Connect will be the documentation. Also, Sats Connect is open source, so you can visit the GitHub repo. Both of the links are here in the resources. And also you can visit the experts Discord, where we have a dedicated channel about Sats Connect, where you will interact with experts team, other people that use Sats Connect and other builders as well. And I'm looking forward to having you and interacting with you guys and answering your questions. And good luck for you in your quest to build on top of Bitcoin. Bye.